In Algebra 1, everyone learned to write domain and range using inequality notation. In Algebra 2, we'll be using two different types of notation, set builder notation and interval notation. So first, it's good to remember what exactly domain and range are. So domain is the x values and range is the y values. I always like to remember this by knowing D comes first in the alphabet, therefore X goes with domain, and range comes second, and therefore Y goes with range. So how I determine domain is your X value, so you look at your x-axis, and you ask yourself, what is my least X value? You always want to start with your least value and then move on to your max value. So how far down the x-axis do I go before my function stops? And on this number 1, it is clear that I can only go down to 1, 2, 3, 4, 5, 6, -6. This point right here stops at -6. So my lowest x value is -6, my least x value. So I know that I'm going to start at -6. Now first I'm going to show you what is called interval notation. And all you do is first write down your lowest value for your domain, which is -6. And because it actually touches -6, if I were to draw a line up from -6, the point is directly on that -6. It is a closed dot. So therefore, because it is touching -6, I put a bracket. Next, we have to ask ourselves what our max value is. So I'm going to go now in the positive direction on the x-axis, and I stop where my function stops. And it stops at 1, 2, 3, 4, 5, 6. So my max value here is actually 6. And it is touching 6. It's a closed dot on the x value of 6. So because it is touching 6, I put a bracket. And let's figure out range. Range is your y value, so I'm now looking at my y-axis. And I ask myself, how low on the y-axis do I go? And actually, I don't go in the negative direction at all. It stops directly when y is 0. So I'm starting at 0, 0. I can't go any lower. The lowest point on my function stops when y is 0. And it is touching 0. You can see it's right there on that x-axis. So when y is 0, we have a closed dot, a closed point. So it is touching 0, so I put a bracket. And then if I'm going in the positive direction on the y-axis, I stop at the y value of 1, 2, 3, 4, 5, 6. And this is actually on the y-axis with a value of 6, with a closed dot. So it is touching 6, so again, I put a bracket. And how we determine whether a function is a function or not, whether a line on a graph is a function or not, is we do what is called the vertical line test. And you guys remember this from Algebra 1. Vertical line test. So that's where if you were to take a pencil and pass it along the graph, as long as there is only one place where your pencil is touching the line, then it is a function. So here, if I were to move this vertical line to the right, so if I start on the left and move it to the right, the line always touches my pencil only in one spot. So yes, it is a function. Now over here, I'd like to try domain and range again, but this time I'm going to do set builder notation, or just called set notation. Now this is similar to inequality in that you are going to have an inequality statement in your notation, but you need to add a few things. So remember, domain is your x values and range is your y. When you're doing set notation, you always start off with a squiggly bracket. And then you put the variable that you're referring to, so domain is x values, so I'm going to put an x. And in Algebra 2, you always put epsilon, which is like a C with a line through it, real numbers. Now, all that this statement means is x is encased in all real numbers. X is in all real numbers. X is all real numbers. And then you do a vertical line, which means such that. And now is where you write your inequality that you're used to. So here, if I'm looking at my graph and I'm on my x-axis, if I'm starting at 0, I really can't go any lower. It stops when x is 0. So my lowest x value is 0. And then, and x is always greater than, and it is touching 0, so I put greater than or equal to, x is greater than or equal to 0. And then I can infinitely keep on going up. That means that I never stop going up on the x-axis. It never stops. Keeps on going until I hit infinity. So I would put is less than, and we can never touch infinity, so I don't put an equal sign there, infinity. Now I can either leave it this way or just the statement x is greater than or equal to 0 is true. I don't actually need to put that infinity there. Because yes, in all cases, x is greater than or equal to 0. Next, with the range, I do the same thing as I did for domain. Y, epsilon, all real numbers, so y is in all real numbers such that, and I ask myself, how low do I go on the y-axis? What is my least y value? And actually, I never stop going down. My least y value is negative infinity. And x is larger than negative infinity. And also, I never stop going up. So my max value is also infinity. Now, this is not wrong. This is the statement that you can put. However, whenever we have, oh my gosh, should have put y. Sorry. Whenever we have our values going all the way from negative infinity to infinity, that is the definition of all real numbers. So we can just put y's in all real numbers. And then, again, we do the vertical line test to see if this is a function, and actually it is not. My pencil would touch the line in 2 places, making it not a function. And lastly, I want to go back and do another interval notation example. So again, this is interval notation. So my domain is my x values. I ask myself, what is my least x value? So on my x-axis, I keep on going down, and I have to stop at the x value of negative 3. Now, because this is an open dot here, it means that this function is not actually touching negative 3. It is all the values all the way up to almost negative 3, but not actually equaling negative 3. So whenever you have an open dot like that, you have to do a parenthesis. So before, we did all brackets, and that's because all of our points were closed dots. They were actually touching all of those numbers. So we had to do a bracket. So now we're learning when it's an open dot, we use a parenthesis. And our lowest value is negative 3. And our max x value, if I go in the positive direction here, our max x value is a value of 1, 2, 3, 4. And again, it's an open dot, so I have to do a parenthesis. And this means the domain goes from negative 3 to 4, not actually equaling either of those numbers. Let's try range. Our lowest y value actually stops right there when y is 0. So our lowest y value is 0, and it's actually on 0. That's a closed dot there. So I put a bracket. And when I go in the positive direction, my max y value is 1, 2, 3, 4, 5. And both of those are open dots, so I have to put a parenthesis. And is this a function? We do the vertical line test. And yes, in all places, my pencil only touches the function in one spot. So yes, it is a function. So there are the two different notations that we'll be using in Algebra 2.